For this project, I was in charge of the networking aspect of it, getting the router, switch, everything plugged in, configured, etc. So starting with the server, I set the IP address as 10.0.1.1/24, like the 24-bit net mask. So our entire internal network was 10.0.1 dot whatever with a 255.255.255 submasks. Then we had that server plugged into a switch. Then from the switch, we had it plugged into a router. The internal interface was fast Ethernet 0, 1. That interface's IP address was 10.0.1.2. And the external interface was the 0, 1 fast Ethernet with an IP address of 172.16.0.1. That was a 16-bit subnet for connecting to our partner team. On the router, we had PAT configured, so the port address translation. We did some overloading from the internal network to the external one. Maybe it wouldn't have been the best choice for a larger network, but it felt appropriate for the smaller scale of what we were doing, especially since we didn't need that full infrastructure just yet. So that's about it for the networking aspect of what I did. And Sandeep is going to finish up telling us about what actually we have on the server that we're connecting.
Hello, my name is Sandeep Kattepogu, and I designed the web/VM server we used for this project. As for the technology we used VirtualBox 5.2 to create our virtualization software. The most alluring parts of this software were that it can create VMs over the network available by port, which makes moving to AWS very easy, but also an extension called VirtualBox Extension Pack 5.2.4 makes these VMs visible over RDP, making our job of serving the VMs very easy. I also decided to use Python 3 to create both our web server and to take care of accepting requests to spin up VMs and download RDP files for them. We chose that because it was very simple to deploy straight from a single script. Now, in order to get Python to work as a server in a script, we had to choose a web framework to make that happen. Initially, we chose Bottle, but it turned out to be too simple for our taste because it couldn't handle sessions. For that reason, we chose Flask as our web framework to get Python to work as a server in a script. And we use Flask to launch our web server, and it serves as a very usable front end to VirtualBox. Finally, we also used MySQL database on the server internally in order to store details about each VM that was created, apart from what VirtualBox records about VMs, just to make our lives a little bit easier. As for network details, as Jathen might have mentioned, we set our IP address as 10.10.26.102, and we're serving our website over port 8080. We originally decided to have our domain name visible over the network, but that might have required messing with DNS entries. We decided that we didn't want to include that for the final project. And either way, making that change wouldn't help when moving to the AWS side of the project, as we need to buy a full domain name in that case. As for the architecture on the server itself, we are going to look at the file system to understand what's going on. If you go straight into the root of the server, the first thing you're going to have to notice is the bin folder. This bin folder contains the binaries for VirtualBox itself, and as you can tell, is very important to the operations of everything else working, including the website and the RDP server. Now, next thing that's important is the cloud folder. And this cloud folder contains everything we need to run our server apart from the users themselves and the binary files for VirtualBox. Under web app, we have the web app itself and the different files it uses, including the HTML files it serves, the authentication script that authenticates users with the file service, and various other important website files that we store there. Under VMEXE, that contains the files, the scripts that copy VMs from templates, spins them up, personalizes them with usernames, and possibly later with passwords, and includes various other quality of life things such as getting ports by VM name. And under the devs folder, here is where we store all of the template hard disk files. And when you start up the server, it copies from this devs folder a certain hard disk file and places it inside the user's devs directory. Now, speaking of the users, underneath each user on the system that will have VMs created for them, they each have a devs and a VMs folder. The devs folder contains the hard drives for all the VMs they create, and the VMs folder contains all of the necessary .vbox files and any settings that those require to get the VMs to be served. Now let's look at the procedure details. The first thing that happens is that the user connects to our website. Again, originally we had it that they connected DOS.com, but we decided to allow connection by IP address instead. The second step is that the router passes the request to the switch, which we got working using RIPv2 instead of using NAT, which would have complicated most of our procedures down the line, including possibly making it more difficult when we port the server to AWS. The next step is that the web server accepts the response and serves a login page. This is what the login page looks like, and we have authentication working as it needs to. Now, once the user logs in, they are served the create page. The creation page contains various fields for the user to specify, including name and type. Down the line, we plan on including a password field, a hard disk space field, and memory allocation. These will be served by creating even more templates than we already have and won't be too difficult to create before we move the app to AWS. The next step after getting to the create page is that the launch VM button is pressed. Now, what that does is that it launches methods within the Python script that spins up the VM by first copying the hard drive file into the user's devs directory. We have the spinning up working, we have the customization working, except with the password not being set correctly. And we also have the port being opened up so that the user can log into the VM and interact with it. The next step is that the user refreshes the page and sees that the button for their VM is now unlocked and enabled. Once they press that button, an RDP file will be served over HTTP for them to use, and they will be allowed to connect to the VM itself, as you can see here. This was implemented fully, and the only thing is we may at one point include external authentication, but that isn't a necessity. It's not necessarily in the scope of what we want to do. Finally, what we want to get working down the line is getting power on and power off buttons working for the VMs so that the VMs don't have to be powered on all the time. And we plan on adding a delete button so that users can delete what they don't need, because currently the page as you can see over here, doesn't include any of those buttons and only includes the buttons for downloading the RDP file. And with that, the explanation of the web VM server is finished.